Good afternoon. Welcome to this live session on VLSI physical design with timing analysis. We'll start the session after some time. First of all, I would like to thank all of you to enroll in this course. Hope it is useful for your career and future, and it will be. I would like to interact with you during this live session. Okay, we'll start some of the questions. So the chart, where is the chart actually? Okay, this one. So if you have any questions, you can write in the chat also. Okay, so I think there is no question in the chat, so we'll start those questions. Okay. Question number? No, they initially did that one.
Question number? These are assignments related.
Okay, we can complete that one. Okay. Okay, you have joined. I think I need to open that file, man. Oh. This one.
Slide.
Right. Solution.
Weekly.
Weekly. Okay.
Last question.
So I need to share this slide. So this question, no? Question number in assignment 3, 7 to 9. This one, no?
Yeah.
Okay. So I'll go. Okay, I'll share first. If you go there, it's the entire screen.
Question.
Just will finish this course and. So there was a question. Okay, there are some people are still there. Okay, so basically there was a question that week 3 and assignment 3 7 to 9, question 7 to 9. So if we go to this question, this is the circuit diagram, and this is the delay of all the logic gates. Then we have given arrival time at the primary input ABCD 0 by 0, and the required time at the primary output node is 16 by 13. So we want to find the arrival time at node J. Okay, node J. So basically, if you can see this one, so then we'll go to the solution of this one. Yeah, this is the solution. So we need to find the solution of this at this point actually, J, and basically here here we need to find the arrival time. No? Arrival time fall is 6. Okay, arrival time fall is 6. Can you open that question? Okay, so the question arrival time fall output arrival time at node J. This is the node J. Fall arrival time is 6. So just you need to propagate your signal from the primary input to the
Sir, one used to join the
exactly. This one. Okay. Okay. So basically, if you look into that question, we are propagating, calculating from the primary input to the primary output. Your A, B, C, D, E are the primary input, and here the arrival time is 0 by 0 for all the inputs. Then you are adding, let's say this is 4 by 3, then the arrival time at this point is 4 by 3. Similarly, you have to propagate and come to this J node to find the arrival time at node J. For fall arrival time is 6. And all the basically formulas for the inverting and non-inverting is gate is provided here. You can refer to this formula to solve this question. Similarly, if you can go to second question, the rise input
required time at node.
Question number 8, rise input required time at node G. Node G is this one. Required time is basically -3. Okay, because it's a rise, so -3. So there was a question in the discussion from why I am taking the minimum, why not I am taking the maximum. Whenever I am propagating from primary input to the primary output, I am taking the maximum. But whenever I am finding the required time, I have two things, -3 and 1. So basically the -3 will give you the worst case required time. Okay, so that's why this -3 is taken. So this minimum value will give you the worst case required time. So that's why so minus minimum of both the required time is taken when there is a fan out of uh, fan out of fan out of the nets actually. This G node has two fan outs, so you have to find the required time in both the direction and take the minimum to find the worst case required time.
So,
okay. So any similarly you can we have one more question. Slag at node H. Slag at node H, which is basically 0 by uh, 0 by -4. Okay. Then you have this one also we discussed, no? G we discussed. Then 9 is 0 by -4. Then one more question. No. Okay, so we discussed all the solution from 7 to 9. So basically, I'll suggest you work from primary input to the primary output, and whenever you are working for the primary input to the primary output, you will find the arrival time at each of the nodes. Then from primary output to the primary input, whenever we are calculating, you will find the required time at each of the nodes. And since you know the required time and arrival time, then from that you can find the slag. Okay. So required time and the arrival time, you can find the slag. Okay. Any other questions? Okay, there was a question in the chat actually. We can answer that question. Sir, in RTL design, it is said that in ASM chart, we do not use multiple if else statement, use cascaded if else statement instead. Oh, why, sir? If else statement will be a combination circuit, so we can use more than one. So this is not part of this course actually, VLSI physical. It is towards the article design. I don't want to comment at this stage actually. Okay, please ask from my course. Okay. Okay. There is initial delay, na? When initial delay is greater than the tx delay, then the new data. This is the question. I think what is the slide number? Can they?
Okay, yes. Slide.
As far I remember. Slide basically. What is this now?
Please about it.
I is 11th, 6, 7, 8, 9, 10.
Lecture 10.
10 है?
हाँ.
Oh, what is the question actually?
Why data cannot correct?
Where the data cannot corrupt the value present at W node, W node in delay of the this transmission rate is less than T initial and T initial is greater than should be considered to hold time violation because T1 is turned off at positive. T1 is turned off at positive is in this case even if the data changes at node D, that does not affect the value at node D. If I am wrong, please explain. Thank you. Okay. Basically, the main point here is that if your whenever this T1 will be closed, then your data at W node is safe. Okay, and there is no hold violation. If your basically uh, delay of uh, T of Tx is less than T initial, okay, so what is happening here means the T initial is larger. This is larger. If T initial is larger, then the data will never come to this point actually. Okay, since data will not come to this point, then it will never corrupt W. So your hold time is negative. But if your delay of the TTX is larger than T initial, so your transmission gate is TX1 is opening for a longer period than T initial, then what will happen is that the data will easily pass through your transmission gate and come to your W. Okay. So data will pass through the transmission gate and will reach the W. So in this case, your hold time is positive. Okay. Any next question?
Next question. Like slide number 12.
Slide number 12. What is that question actually? Why the flip-flop is not sampling the data at age 2? So kindly clarify my doubt. Okay, flip-flop 2 is not sampling at age 2. So we are considering the max timing constant, considering skew. So in that case, whenever you are considering the max timing constant, we have to consider two basically two edges. Means clock 1 age 1, clock flip flop 1 age 1, and flip flop 2 age 4. So if so in that case you have basically so whenever you have a setup or max timing analysis you are doing, you have to consider two different edges of the clock. One for the flip flop 1 and one for the flip flop 2.
New student.
Okay. So basically, yeah, this one, correct. So basically, the reason is that whenever you are doing max timing analysis or setup time analysis, we have to consider two edges. So in this case, we are considering two edges, this 1 and 4 edges for timing analysis. But for hold time, we have to consider the same edge. Same edge means the one clock one for the flip flop one and clock 2 for the flip flop 2, such that then we should not have any kind of hold violation. Okay, so that's the reason. Basically, main point to remember is that for setup time or the max timing analysis, you have to consider the two clock edges of the clock, and for hold time or minimum timing analysis, you have to consider the same clock edge. Okay, so you have to consider the same clock edge. So in this case, the 1 and 2 for hold violation or the minimum timing analysis. Okay, so any questions in the chat? Okay. How to find a required time? Yeah. So it is explained in the PPT, but again, if you want, for example, so here you have 16 by 13. Okay. This is the required time at the output node. So whenever you are finding the required time, always you find from the primary output to the primary input. These are the primary input. A, B, C, D are the primary input. N is your primary output. So first of all, the required time is given here 16 by 13. So now here if you can look into that input rise required time. Okay, input rise required time. So in this one should the minimum output rise time minus T rise. So here output rise required time is 16. 16 minus T rise. 16 minus T rise is 15. So 16 minus 1, this is 16 minus 1 is 15 here. So this arrow is visible to them?
Yes.
Okay. So here you have 16, which is this value, rise required time, minus rise delay, T rise, will give you 15, which is the required time at node M. Similarly, you have output fall required time, which is 13, because this is the output of the gate. Oh, sorry. This is applicable for non-inverting gate. If you are doing for inverting, then the formulas will be different. So this is a buffer. That's why it is 13 minus 2, it will be 11. Okay. So you have to remember, or means these are all I derived in the lecture actually. In case it is difficult for you, it is better to remember them. Otherwise, all the derivations I did in the lecture actually. So similarly, you can if you have to first look into the type of the logic gate and the output required time and the rise and fall delay to find the input required time. Okay. So Could you clarify the question? As in, is it confusing how question number 5, assignment 5, question number 3? Is it confusing how that the C node, which is on the top, appears early in the police since we do this in order? Okay. Assignment,
Yes, sir.
assignment number 5 actually. Question number 3. 3.
Okay, question number
3.
this one.
Okay. Okay, I have to open that one. What it is?
Assignment 5. Yes. Okay. This one.
This one. So what is the question that?
See,
So it is in order. In order, what is the question for this? In order digit.
policy.
Policy means postfix, no? It should be like E, F and then V star, no? Like this. This is the solution for this question actually. Basically, A, B, then H is plus. Okay, A, B, then plus. Then you have to go then extreme, then C, okay, then D, okay, then E, like this, then
Yeah.
F, then you have to go to this B is multiplication, then H is addition, and then another H is addition, then multiplication. Okay, so this is A, B plus C, D, E, F star plus plus star. Okay, so this is the basically polished expression. Basically, you have to do left, then right, then the node, root node actually, or the parent node. The left child, then the right child, then the parent node. That is called polished notation. So similarly, you have to move. Since we are in the left A, then right is B, then the parent node is H. H is plus, so AB plus. Okay. Similarly, we have to go to the extreme in the left side, which is C. So C is coming because of that. Then you have again go to the extreme left child D, then D, then you have E. Then after E there is no left child, so I am going to the right child, which is F. After F we are going to the nearest parent, which is B. B is basically multiplication. Similarly, you have to go H. H is plus. Okay, then you have stars multiplication. Okay.
Hello, sir.
Hello.
Sir, that was my question. My
Yes.
name is Shri. So I was basically confused about how the C node appears to the left of the H node in the slicing tree, because the C node is on the topmost. So that's where I got stuck a little bit.
C node.
Yeah. So when I did the slicing tree, the C node was the right, and all of the H branch was on the left, based on the sliced floor plan.
Say it again. In that, in the this one you're talking about.
Correct, sir. How we translate that sliced floor plan to the slicing tree? In that, the C is actually the top block. So how come it is on the left of the H node? So that's the part where I could not understand that one. That was my primary doubt.
Can you repeat the question again?
So here, when we first take the vertical line,
Hmm.
then A and B is to the left of that vertical line.
Right, correct.
So that branch is to the left of V node. That part is
Hmm.
clear.
Hmm.
Now, when I take any one of the horizontal lines to the right of the V node, no matter which one I take, the C node should appear on the right of that uh, horizontal branch. How come it appears on the left of the horizontal branch? Because it is on the top. So if it is on the top, it goes to the right.
See, this is your vertical partition, na?
Yeah.
This is a vertical partition which corresponds to your root node actually.
Okay.
Then this is left. Left means basically A, B, then horizontal partition. Okay.
Okay, sir.
So this left partition, left side is this is corresponding to this one. Then you look into the left side of this. Okay, and in the left side you have A is the below, B is in the top. Then you have a horizontal partition. This one corresponds to this one. Okay.
Okay, sir.
So then you are telling that then you have this side. If you whenever you are going to this side, you have basically two horizontal partitions are there. Then you have a
Yeah.
vertical partition. Okay, so either you can have the C and D can be exchanged also. Then this is nothing, will partition will not change. But let's say we did the partition here, this one.
Okay.
Okay, so this one whenever I partitioned, okay, so then I have C in the top, okay, and left side is the below. Sorry, right side is the below.
So for a horizontal node, the right
Um,
part should go to the left branch. Is my understanding correct? That way, the C node has to go to the right of that H node.
C should be
How come C node? Yeah, because it's in the top.
okay. C node is in the top. Then C node is in the top means you are telling that A, B, like B is in the right, C should be also in the right.
Exactly, sir.
Okay. I'll look into it and reply you. Okay.
Okay,
Uh,
sir.
I,
Thank you, sir.
I guess then if you do like this, then B is also in the right. So the tree will look like slightly different here. I'll look into it.
Exactly, sir.
Okay, I'll
Yeah.
look into it and reply. Okay.
Thank you, sir.
Okay. Next.
Just
So okay. Could you please clarify the required time for both inverting and non-inverting cases? We have just discussed that, and that derivation will really take 1 hour class actually. You better just go through this lecture again. I suggest you don't remember formula, but I derived basically there. Okay. Please look into that how the derivation is happening. Then you don't need to remember whether it is an inverting or a non-inverting gate actually. Okay, whether it is a inverting or a non-inverting gate. So it is not difficult. Please go through it actually. Shreyas, explain the force direct replacement. So if you have any particular question, then I can answer. Otherwise, it will be like teaching the complete force direct replacement. Please go through the lecture. Could you please explain the question number 4 in week 3 assignment? Question number 4. This same.
About
Oh,
for
okay. So the question is related to
actually some students consider only one case, so
okay,
they are
two.
getting 3.5 answer.
Okay.
That's why they are asking. But we have to consider both case.
Two
And we have to
yeah.
consider minimum out of two case.
Okay, two jitter. That's one. Okay, the question is related to two jitter. Why it is two jitter? That is the question. Uh,
Yes.
Naga.
Varshita.
Varshita, is it related to this two jitter? That is the case. Or you want to understand the complete thing. It has two different analysis. One is max timing analysis considering clock skew. One is mean timing analysis considering the clock. Sorry, max timing analysis considering the clock jitter. Mean timing analysis considering the clock jitter. In both the cases, if I have no jitter, then this is the formula. T clock should be greater than equals to T clock TQ maximum plus T combination linear plus T setup. Now you are adding two T jitter. Now you have two T jitter. So for that one, this you are finding the jitter value here. So jitter is 3.5 nanosecond. So similarly you are calculating for the hold, and in that case we are taking the jitter. So max level jitter is mean लेना पड़ेगा क्या?
You can say the minimum out of.
This is the question. You can take
What is the electric
question. Here is a question now. What is the maximum allowed jitter in the clock so that the given circuit works at a keeping frequency without failure? So for this one is 3.5 होगा हाँ तो पहले भी कोई पूछा था क्या इसको
इसको हम क्वेरी
actually what is the question here? Okay. This is the question. Why do you think it is 1.5?
So
Suppose if you increase this value, then
सपोज टी डेटा अगर 1.5 अगर कंसिडर करेंगे
हाँ
तो क्लॉक है टी क्लॉक हमारा कम इंक्रीज होगा
ओके
तो फ्रीक्वेंसी मैक्सिमम रहेगा
ओके इसी दैट सेंस
हाँ दैट इज
ओके
अगर हम 3.5 लेंगे तो क्लॉक हमारा
हाँ
टी क्लॉक मैक्सिमम हो जाएगा तो
okay
फ्रीक्वेंसी
where is the question again so what is the maximum allowable jitter मैक्सिमम फ्रीक्वेंसी में रन करने के लिए नहीं पूछा गया ना तो कितना मैक्सिमम दे सकते हो इस सेंस में
बट क्लॉक पीरियड 20 है
हाँ क्लॉक में 20 है ओके आई गॉट देन 3.5 होगा ना क्लॉक में 20 है तो दैट वाज 3.5
नहीं लेस देन है ना लेस देन और इक्वल टू तो 3.5 भी कंसिडर कर सकते हैं लेकिन हमको क्या है विदाउट फेलियर ना तो मिनिमम ही कंसिडर करेंगे ताकि वो एक बाउंड्री में रहेगा पर्टिकुलर रेंज में तो ये वाला केस आएगा ही नहीं कि वो फेलियर ही नहीं होगा
ओके इसलिए लिखा
हाँ इसलिए मिनिमम कंसिडर किया है
नहीं तो देन दे विल टेल दैट 3.5 के 2.5 पे चल जाएगा 1.5 पे चल जाएगा 1 पे चल जाएगा ना ऑल द क्वेश्चंस आर करेक्ट राइट
नहीं पर बहुत केस कंसिडर करेंगे तो केवल हमारी यही रेंज आ रही है 1.5 से 3.5
हाँ वो बोले ना
वैसे पॉसिबिलिटी तो है
हाँ
जैसे
ओके ये इसका ग्रेडिंग हो चुका है हैं तो देखेंगे we'll look into this question again okay and get back to you in the discussion forum we'll post the answer actually okay so then what is that actually where can I find the recordings of the previous lectures what is that actually Badrinath what is that actually can you
everything is on for time
this one is done no this one is done slicing tree right branch and left branch seems swapped actually then basically why it is said that this is a question somebody asked na in
paper
correct so it is very not very clear actually Devars Dubey it is said that if the pulse width of the applied signal is less than the delay of the clock uh, then then is desired output is not expected or no output is expected but at the same time when positive is clock delta like pulse is applied then expected output also the positive pulse width is small than the input signal majority of the times is obtained. Why sir? Again I have to read that. This question is not very clear actually. If the pulse width of the signal is less than the delay of the block actually. Block यहाँ पर block लिखा है. Then the proper output is not achieved. But on the other hand, if the clock positive pulse is given, then it has having no problem in output. This is related to whatever you are telling. Is related. The first one is related to combinational circuits. Okay, when the pulse width is smaller than the delay of the block, then the output will not change. Okay, the propagation circuit delay will not, because of the inertial delay of the combination circuit, it will not appear. But on the other hand, if the clock positive pulse is given, then it is having no problem in the output. This is a very good question actually. Now I understand. So in your other things you have written instead of clock you have written it should be block actually. So the question is that the top one is related to combinational circuits. So in combinational circuit, the pulse width should be larger than the delay of the logic circuit, logic block actually. Then only it will appear at the output. But in the case of a clock pulse, small pulse, so then if your input is changing during that time, if a pulse is small width, which is acting as a gate to your transmission gate, which is open for a short interval of time. During that time, if the setup time of the latch is satisfied, then the signal at the input of the latch will propagate to the output. Because the transmission line is one input, a transmission gate is having input to the transmission gate. You have two inputs. One is the clock pulse, which is going to the transmission gate, and the second thing is the data, which is coming from the input to the transmission gate. So basically, if the transmission gate is open for sufficient amount of time, then the latch can sample the data. Latch can sample the data. Okay. So then there is another question, Varsita. So
6B.
6B.
ZFT position of the gate.
Again, I have the solution. Could you please explain the question 8 to 10 in question week 6 assignment? Is there any mistake there?
Sledge. 6. Last 8 to 10. This one.
Okay. I guess there is some formula there for finding this one.
Yeah, solution is perfect.
This question and solution is this one, no?
Yeah.
So what is the issue?
Can you specify your doubt?
Varsita, what is your issue? Eight to 10, no? Question number 8 to 10.
ZFT position of each gate.
Correct. You have to solve. Yeah, I think you have the system of linear equations, no? Three equations, and you have three unknowns. Then you can find the solution of XA, XB, and XC, and then you can take the rounding up to find the solution. Similarly, YA, YB, and YC. Then this is the J, and then finally you get the Z. 0 force target position of gate A, B, and C. Okay. Okay, so this is the question actually related to the ZFT position. So basically, you have block A or gate A location, gate B location, gate C location. Next. Any question? No?
This is the question related to lecture 9.
Okay. So any question? Varsita? Varsita, any question is there? Okay, okay. So then there is a question. Which is, what is the question there? I need to open that slide.
This one.
Slide number PPT.
This question is related to this slide.
Okay. slide number?
Lecture 9.
This one, no? No, where described about capacitance, but mentions cell rise for a function of capacitance also. While how dependency there on capacitance, how the value capacitance measured. Okay, this is a good question. Okay. So what is the question is that why the cell rise and cell fall is depending upon your capacitance. That is the question, na? Here not where desired output capacitance, but mention cell rise and fall are function of the output capacitance actually also. Why? See, basically whenever you have, I cannot write here, no? This one, no.
Presentation.
Presentation.
So I open the slide.
Presentation. Yeah, full screen.
So let's say I have any kind of inverter. Okay, I have a capacitor here. So basically this is your VDD, this is your ground. Let's say whenever I am giving a pulse input or any pulse input to this one. Okay, so it has two parameters. One is this sleeve. Okay, similarly you have a false sleeve also. So this is rise sleeve. Okay, T rise sleeve, P fall sleeve, and you have a load capacitance CL. So cell rise is basically a rise propagation delay. Okay, cell rise, let's say since it's an inverter. So cell rise, how do you define the cell rise? Basically, if I plot in a same scale, okay, let's say this is my input waveform. So this is my input. This is t equal to 0. Okay. So my output waveform, sorry, this is input only. In, and let's say this is in and this is out. So the out here, how it will change? It will be delayed by some amount like this. Okay. So this delay, this 50% to this 50% is the cell fall. This delay is basically your cell fall. And this 50% to this 50%, this delay is basically your cell rise. Okay, so the cell rise will have will depend upon the is a function of basically if you see here cell rise will depend upon what? The fall transition time T fall sleeve comma because this is fall, input is falling, so this is one of the parameters, and load. If my load is changing, let's say load is CL. Now if I change to 2CL, so it will take more time to charge the load. So more time to charge the load means your propagation delay will increase. Okay, if my load capacitance, so all of you understood this, your cell rise will depend upon the input fall sleeve. It is clear for an inverter. because this, if this is the changing, your cell life will change. So this is clear to everyone. But what about the load? If my load is changing, it will take more time to charge that output load capacitance. If you take more time to charge the capacitance, means your cell rise will change. It will take more time. Okay, if your CL will change from CL to CL, your propagation delay will also increase. How much increase will depend upon simulation, but it will, cell rise will increase. Depend upon your load, sleeve, all these conditions. Okay, but cell rise will increase.
Niches.
Hmm. Okay. Any other questions? Chat. Somebody, I think where we are now. This is the last question, no?
No, this is the main.
I have a question on lecture 3J. I have a question on lecture 26, slide shape function in both horizontal and vertical orientation. Why is the point 3 plus 2 is not considered? Could you clarify? Okay, I think it is easy. What is the lecture 26? Which slide?
27.
27, sir.
27, na?
This one.
Correct. What is the problem? I have to read that. 3 plus 2 is not considered. 3 plus 2. You need to check the background a little bit. What is the block size? 3, 4. Okay, this is 1, 3, 3, 1. Then this is 1, 3, 3, 1. Shape function for the block A. Similarly, 2, 4. Then 4, 2, 2, 2, 2, 4, 4, 2. Then you have 2 points. This is the shape function of block P. Now, with these two shape functions, now I am creating the shape function of the overall blocks. So whenever I am creating, so we have to create either in the horizontal composition or vertical composition. Okay, so here it is looking into the vertical composition. So vertical composition means, so one block will be above the other block. So here we have one point is 3, this 3 plus this is basically 4. 4 means this side is 4. Okay, so this 3 plus 4 is 7. Okay, then you have another point 1 plus 5. 1 plus 5, 5 is another point. Similarly, you have 1 plus 2 is basically 3. Okay, so 1 plus 3 is basically another point. So then what is the problem? 3 plus 2. 3 plus 2. Okay, so if you look into it, basically 2, this is basically 4 plus 3. 4 plus 3. Okay, 4 plus 3 is 7. 4 plus 3 is 7. So this is 7. Then another composition is basically the second one is 1 plus 4. 1, this is 1, this is 1 plus 4. 1 plus 4 is 5. This is 1 plus 4 is 5. Height is 5. Then you have one more composition, 3. So 3 is this, basically this one, 3. Okay. So this is the 3 compositions are there. So what is the problem?
So why don't we consider the other two points, sir, for this, for both the compositions, 3 plus 2? Only 3, the 3 combinations are only considered.
Basically, this is related to vertical compositions. Similarly, you have 3 for the horizontal composition actually. If you go here, these are for vertical, horizontal composition. Okay, 3. Okay, so you have 3 composition. I guess what you are asking is not clear to me. Which one we are missing? Can you tell me?
So there are 4 coordinate point combinations, and we are considering only 3 combinations.
I think
So
other one will overlapping with this same thing actually, as far as I remember. Let's say if I take this two size 2, 4, one is another is 3, 1. Okay, basically 3, 1. If I have a pen, basically 3, 1, 2, 4. So it will be 3. If I take one above the other. Okay. So how many possible combinations will be there? See, height is 3, width is 1. Okay, and other one is basically 2, 4. So you have your one is the 5. Let's say height is 5 into 4. Then another is let's say 4. So you are telling 4 composition is possible, no? So 3 plus 2 is 5. 3 plus 2 is 5. And 4 plus 1 is also 5.
yes, sir, but we don't consider 3 plus 2 as part of the shape function. So I didn't understand that.
3 plus 2 is not considered in the shape function of the overall block. Okay. 3 plus 2 is not 3 plus 2 नहीं होगा 3 plus 5 into 4 ना. Let's say on this what is this height actually? P is 2 or 4. 4. This height is 4. This height is 4 plus 1 is 5. Okay. 5. This side is 3. Okay. So 5, 3. And another composition is basically 2 plus 1. Okay. 2 plus 1 is 3. Similarly, you have another is called 5 plus how?
4, 3.
Huh?
4 plus 3.
4 plus 3. 4 plus 3. This is 4 plus 3. Which one is missing? Which one is missing? I guess that condition is inside this already covered in this 3 actually. That's why it was not covered.
Oh, okay, sir.
Just check it actually, because let's
Okay,
say
sir. I
this
will check
3,
again.
4, 3, 4 is there. This side is 3 and this side is 4. This is 7 and which is 2. Okay. This side is 3, this is 4, 7 and 2. And another option is basically 3, one side is 3, other side is 2. No, that is 5. 5 into, how can it is 5 into, how can this one, I mean 4, 4 in one side, other side is 4 in one side, other side is let's say 1. Uh, okay, this which is 4. Okay, and another is 1. This is 2 plus 1. This is 2 and this is 1. So 3 into 4. This is one composition. Then 5 basically. This side is 1 and this side is 4. Then it should be which is 1 plus 4. If I combine, then the width is 3. Which one is missing actually? Which one is missing? Can you tell me?
So the width of block A is 3,
Width,
and the width
width of block A is
3,
3.
uh,
Height
and the
is
width
1.
of
Height is 1.
correct, sir. Height is 1,
Okay.
and the width of block B is 2. So I think those two are the ones that I
Uh,
thought will also be considered.
width of the block is 2.
Block B is 2.
Block B is 2 and height is 4, na?
Height is 4.
Height is 4. So if you look into this one, 4 plus 1 is 5. 5 into 3.
They already covered.
No, no. It is covered in a opposite means you are telling that this should be below and this should be above.
If we, I mean, I think in the other orientation it will come, because it will, if we take width of A plus width of B, is that a legal combination to
No, no,
consider?
no. See, what you are telling is that this is this block A should be below
Yes.
and block B is above. In that case, the same thing will come. 5 into 3.
So I'm trying to look at the first combination, sir, where we have 4 plus 3.
Hmm.
Similarly, instead of 4, oh, we cannot put the, okay. I think I got the point, sir. I was thinking about 3 plus 2, but 2 becomes the width of block B. So if we are considering the width of block A as 3, then we have to consider only uh,
Max
4
of
for
both.
B.
Max of both, no?
Yes, sir.
Max of
I
both,
think I got
it
the
will be
point.
covered here actually.
Yes, sir. I think I
5,
got the point. Thank you, sir.
5 into 3, it will cover. It is the same partition, but A block will be below, B will be above. I think
Okay, sir.
that you're thinking, telling actually. So looks like 2 into 2 should be 4, but you are getting 3. That is your question actually. Yes, ma'am?
Yes, sir. I will recheck, and I think I
Okay,
will
okay,
look into it again, sir. Thank you, sir. Thank you for the time.
okay. Okay, there is no more questions actually. Okay.
Can we take this question?
What is the question actually? How can I change the connections? Okay, that I told in one picture. So which slide actually it is here?
Close related to lab, lecture lab.
Right. The question is interesting. Just lecture you have to open lecture 11, na? This one.
No.
Correct. This slide basically. What is the name? Just to
No.
Nagbabu. Nagbabu. He has asked the question is that how can I change the connection after the chip is fabricated? So I told one technique actually. So it is based on your FEOL and BEOL. FEOL is called the front end of the line and BEOL is your back end of the line, your metal lines actually. So basically what is the point here is that whenever you design bigger chips actually, so what happens is that there might be a chance of hold violation in some part of the chip. To avoid that, this slide is visible to. So basically, to avoid that, what they do is that they add some buffer in the design. So buffers, which is designed here, in this case, basically it is initially it is not connected with in the path actually, and it is isolated buffers. And whenever you see, let's say I have two flip-flops are there, and I have a fold violation in this path. So what it is possible is that since FEOL the till metal 1 or below metal 1 all are manufactured, which is the expensive part of the chip, what people can do is that they can uh, only change the metal 1 mask and read out this small portion and simulate this to avoid this hold violation in this path. So you don't need to pay 2x the cost of the chip cost. Chip will go for fabrication again. However, the cost of the chip will not be two times chip fabrication cost. Let's say the cost of chip fabrication is X. So the second time manufacturing cost will be very much less than X actually. The reason is that all the mask will be used only except the metal 1 mask, which is basically having the issue of the hold violation, which is rerouted. That portion will be reprinted. One or two masks will be reprinted, and that too in metal mask, which is cheaper compared to the transistor level mask actually. So that's the reason I told this is a trick used in many of the industries where if they have hold violation, they fix this using this technique. During the chip design time, they will add these buffers, isolated buffers, which will be reconnected if there is any kind of hold violation in any path. This is a very good question actually. Okay, so if there is no more questions, then we'll stop here. Thank you for joining the live session.